Okay, we're back on this 2008 Prius. In the previous 3 videos, I think it was, you've seen the steps I went through when it came in here low on charge, dirty air filter, looking for leaks, showing you the sight glass with the low refrigerant level and it all foaming up and moving around. So now I charged the system back. If you remember, liquid line temperature, in the last video I was showing you, the compressor was at 200 degrees Fahrenheit. Now we're at 91. This is with a full AC refrigerant system. So right now we have 91 degrees. Let's follow the high side temperature sensor, and we're going back down here. We're back down on the discharge line of the compressor. That's the hot line that was 200 degrees. If you look over at the compressor on the suction line, tell me what you see. So I can focus. Come on. Water. You see the water droplets? The whole hose is so cold, it's below the dew point, and even the case of the part of the case of the compressor. So if you put your finger, without chopping my finger on the fan, here's the line, and you can see the water. See the water? Here's the case, and there's water there. That's how cold the case is. This is what happens. That's to cool your electric windings of your compressor. All the energy used, all those watts of power that are being used to run the compressor are being cooled off and chilled and lubricated with the oil coming back for the mechanical part of the compressor, and the cool gas flow cools off your compressor. Well, when you don't have that, and this compressor is making a little noise, and I could feel it with my fingers. It's not the fan. I could feel a vibration in the discharge hose. There's actually a little vibration, a ticking noise. So this compressor was ran low on charge, kind of like with those guys who fill up cars by cans and go by dash temperature. They get it cold, but it's a little low on refrigerant, but it feels really cool out the dash. But the compressor starves for oil flow return and cooling. So here's our suction line temperature coming back from the evaporator, and that is off this line right here. So here's our temperature probe, and I have it back there, and you see I have it all wrapped. The line is back there, and I'm attached onto the line, and it's all wrapped in rags because you have this hot air blowing, and I'm right above the exhaust manifold. So radiant heat will bounce up and heat up my clamp, and the heat will travel through the plastic to the temperature sensor on the pipe, and it'll give me a higher false reading. So you need to protect your probes from radiant or blowing air heat. So here's our pressure. Remember before we were like 3 psi when we were low. And remember we were low on pressure over here. We're about the same. So the high is still about the same. So now I'm going to take this liquid line temperature probe, and I'm going to move it up to the liquid line back where I had it before. So remember, this is the temperature of the gas that is going as a hot vapor into the top of the condenser. So now I'm going to grab that line without taking off some fingernails on the fan. Oh, nope, there goes a fingernail. Okay, so let's try this another way. Remember, children, don't do this at home. You could lose fingers. It's only a Prius fan. It's not a 1969 Mercedes-Benz with the big metal fan spinning. Priuses are for little snowflakes. Okay, so now I'm going to go back to where I was taking the temperature. See the liquid line? It comes there, it goes down. That's where I took my temperature before. So this is the temperature of the refrigerant coming out of the bottom of the condenser. So now I'm taking the temperature at this location. So that means the hot discharge gas went through the top of the condenser at the connection here, went through all the multiple passes of the condenser, came out of the low line. Let's see it right there. That line with the insulation on it, that's the liquid discharge. So I'm taking that temperature. I just don't have access right here unless I pull this out, and I don't want to pull them out because sometimes the plastic breaks and doesn't go back on. So right there, and it travels up this line and it goes right there, and that's where I'm taking the temperature at. Now look at the temperature has fallen. So the air temperature outside is this, 68 degrees, and that is being provided by us by this temperature sensor right here. And I have this temperature sensor sitting at the intake of the air that's going to go across the condenser. So that air is 68, 70 degrees, and we have a refrigerant discharge temperature about 6 degrees or so above that. But remember, we were only like 80 some degrees, 86 degrees going into the condenser. Now this temperature will be a little higher, so where I'm taking this is not the right place to take the temperature. This temperature probe should be connected at that fitting coming right out of the condenser, and so it'll probably be a little hotter than that. Instead of 76, it'll probably be about 80 degrees coming out of the condenser. Very little temperature drop. And if you listen to the compressor, remember before when it was low on refrigerant, how the compressor was winding, and it was just winding the piss out of itself, just trying to catch up to move enough refrigerant to call for cooling that you were requesting on your dash, but it couldn't provide. So it's a dumb system. It only knows, it doesn't know it's low on refrigerant, it only knows my boss hit the button and said, you must give me my 65 degrees. So it ramps up the compressor 500 RPMs, another until it's 6,000 to 7,000 RPMs. At the same time, it's cooking itself and mechanically eating itself up. And this is what happens when you allow your compressor to run low on refrigerant. This person has been doing it all winter long. When you're in the morning, you have defrost. The inside you're running your compressor, your AC, to defrost and remove the humidity out of the car to defrost your windshield, but at the same time you have it on heat, so you never know you're actually cooking your compressor all winter long. Now spring came along, the sun is coming out, and you call for cooling, but it was low. So now you're not only low, but you've already damaged your compressor. And this is the life cycle in the chain of events, what happens when people routinely let their AC compressor run low on refrigerant. So take a look back at the last 3 videos when this 2008 Prius came into the shop, from the very first inspection up to now. The very last video showed a vapor hot gas discharge out of the compressor of 200 degrees. That's it on this vehicle. I'll post this up on Prius chat.